It's homework time, yes! Here we go again. Let's start by putting our name down at the top of our homework paper. I'll put my name and you write yours. Now let's write today's date. You write the actual date, where and when you are in this wonderful world of ours. And I'll write today. Our instructions, if you dare. Draw a tape diagram to represent each addend. Those are the numbers we're adding, 7/8 plus 1/4. For example, decompose one of the tape diagrams to make like units. And by like units, we're talking about having the same denominator, the same digit at the bottom of each fraction, like we have eighths and fourths, We're going to make them, well, spoiler alert, we're going to make them both eighths. This one's already eighths, so we'll turn the fourths into eighths using our magical decomposition methods. Then we'll write a complete number sentence and use a number bond to write each sum as a mixed number. Very similar to what we're doing last time. By the way, this is the last, yeah it is. This is the last lesson here before your mid-module assessment. So, yeah. So do that. All right, here we go. So I'm going to draw tape diagrams. Let me go ahead and just do all 4 of these. And I'd recommend to do likewise. Go ahead and draw out your 4 tapes for A and B. Get things all set up, you know. And they don't have to be too big because we're just dealing with eighths and fourths, thankfully here. No 12ths, 15ths, or 18ths, or 24ths, or 2000ths quite yet. All right, so that does it. All right, so now I'm going to, in both cases, even though it's listed second, I'm going to put fourths on top. So let's do 1/4 to start with. So cut it in half and then partition each half. Gives me pretty good fourths. That's baby's 1/4. There we go, 1/4. And then I need to do 7/8. So I can start off by doing the same as above, drawing fourths. And now there's 2 ways, at least, that I could do this. I could bisect each fourth to make eighth, or I could draw a line down the center. I'm going to go with the bisection method. And when you double up on fourths, you end up with eighths. And so 7 of those. And we could see as we shade in this 7/8 that we are going to have a sum that is greater than 1. You can tell just by looking at the picture. Let me switch colors, and you may want to, before I do, hold on, let me just write 7/8 here. I'm going to switch colors because I'm going on to decompose the fourths into eighths, and it's as easy as duplicating what I had below in terms of the partitions. And when I draw, I make this one nice and heavy so you can see it over my scribble scrabble. There we go. And so now this is eighths, right? And how many eighths? Switch back to black. You got it. You can count to 2, can't you? It's 2/8. So then what we're really adding here is we're adding 7/8, or not really adding, but in order to make it easier, 7/8 plus 2/8, which of course is simply 9/8. And our number bond, I'm going to do it sideways because I don't have the room underneath here. We can pull out the 8/8, which is equal to 1 whole, and that leaves us with 1 more eighth. And so the 8/8 is equal to 1 whole, and then we have 1/8. So the answer is 1 and 1/8. So we did everything. We did a tape diagram to represent each one. We decomposed the fourths into eighths, wrote a complete number sentence. There it is. And we used a number bond right here to write each sum as a mixed number right there. We did it all. We're good. All right, so again, I'm going to do the fourths on top. I don't know, it just makes sense. It gives me visual balance. There's no reason. So there's my 2/4, 1, 2. And now, and maybe this is why I like doing a fourths on top. So when I go to do eighths, I can duplicate. What I'm doing is I'm visually lining up these lines. I mean, if you're going to draw tape diagrams, they might as well look good, right? I hope yours look better than mine. They probably do. It's okay. I can live with that. All right, and then I'm adding to it 4/8, so 3 and 4. And you probably noticed something, don't you? 4 is half of 8, 2 is half of 4. Oh, these are both equivalent fractions for 1/2. And 1/2 plus 1/2, we can make a pretty good guess at what our sum is going to be. Well, let's go ahead through it. So here, I'm going to decompose my fourths into eighths. And as I mentioned in the last lesson, I'm not going into too much detail on why and how, wherefore we're doing this, because we did so much of this already with equivalent fractions, and we're essentially doing the same thing. And so now my fourths are eighths, and my 2/4 is equal to how many eighths? 1, 2, 3, 4. 4 eighths. Ah, I see, they are equivalent. They're both equal to 1/2 as well. So really, now what I'm looking at this as is 4 eighths and 4 eighths, which equals 8 eighths. And I realize I'm supposed to use a number bond, but here's my number bond. It's 1. 8 eighths equals 1. There we go. All right, I think we have a little more on number 1. A C and D. Yes, let's check it out. Yeah, sure enough, C and D, here we go. So we're going to do more of the same. I like to do things sometimes in this little systematic factory processing manner. So I'm going to draw, I'm doing 6 and halves here. So I'm going to go ahead and draw my 2 tapes. And you want to make these as close to about the same size as you can. I'm doing my darndest. And again, I hope yours are even better. And here we're dealing with fifths and tenths. But we have ways of dealing with fifths and tenths. That was horrible, sorry. Okay. All right, so let's go ahead and draw 1/2. Ready? Oh, there we go, done. And I'm going to shade in my 1/2. Scribble, scrabbly. Scribble, scrabble, scribble, scrabble. Ice skating, yeah. And this is 1/2. And now we're going to do 4 6. All right, so how should we do this? Well, I think we should do thirds and then bisect the thirds to make sixths. And so it's going to look like this. We'll do thirds. Those are pretty good. Not great, but good enough. And I can kind of cheese out here and bisect them horizontally. So I don't have to draw as many lines, just that one straight across. And we're talking about 4 6. 1, 2, 3, 4, which you probably notice is equal to 2/3. Do you see that? You getting to where you can see those? I hope so. I am. All right, so sorry, we still need to go ahead now and decompose the 1/2 now. We have to turn this 1/2 into sixths. Okay, so the best way to do it, what is it a factor of? In other words, what's the relationship between 2 and 6? 2, 6. 2 times 3 is 6. That means each of these halves needs to have 3 partitions, 3 decompositions. So here, this half and this half. So 3 rows. Remember doing the 3 rows, 2 rows thing some time ago with equivalent fractions? And now switch back in black. All right, so this 1/2 here is how many sixths? It is 3 6. Yes, we can count. All right, so now what we're adding, which we can actually add, is 4 6 and 3 6, which of course gives us, that's right, 7 6. And to make a little number bond from this, and again, I'm doing it horizontally just for space restrictions, I'm going to pull out the 1 whole as 6 6. Why? Because we're talking about 6, Ed. And that leaves 1 6. Which then in turn is equal to, well, the 6 6 is 1 whole, and 1 6 is 1 6. There we go. Every step. Beautiful. All right, so now here I'm going to do the fifths up top. You notice I like to do the lower digit denominator first. Now, doing fifths can be a little tricky, but we just have to draw 4 equally spaced lines in here, or relatively equally spaced. 1, 2, 3, 4. Oh, that's one of my better ones, isn't it? And we're going to scribble scrabble in 3 of them. 1, 2, 3. And now I can duplicate those lines. You know where I'm going with this. You do. 1, 2, 3, 4. And then to make this tenths, to do my 8 tenths, I can just draw that horizontal line of decomposition. So this is 3 fifths up here. And this is about to be 8 tenths. 1, 2, 3, 4, 5, 6, 7, 8. You like? You like? Good. Alright, so now I'm going to switch colors up so we can see my lines of decomposition. And I can do the same thing I did on the bottom here to decompose fifths as tenths. Go straight across. Drawing straight lines is hard, says Barbie. Okay, so now how many tenths is 3/5? 2, 4, 6. Yes, 6 tenths. So now what I'm adding is 3/5 in the form renamed as 6 tenths, so we have the same denominator. And adding that to the same old 8 tenths gives me, well, 6 and 8 are, yep, 14. And we're talking about tenths. Now, to do my little number bond, again, I'm going to do it horizontally. I'll pull out the 1 whole. We're talking about tenths, Ed. So it's 10 tenths is my 1 whole. And that leaves how many from the 14? Another 4 tenths. There, right? And so that equals, well, the 10 tenths is 1, and 4 tenths is, 4 tenths. And we could simplify that, but that's not in the cards, is it? Let's go on to number 2. All right, in number 2, look, we're doing the same thing. The only difference is that we'll use a number line to model the addition. Same thing then, number sentence, number bond, write it as a mixed number. Okay, so let's draw 2 number lines to start off here. And we should estimate, we could see 5/8 is more than a half because 4/8 would be a half. And so we're adding that to a half. So our number line has to go over 1. So I'm going to draw a nice long line. Might as well do the other one while I'm in the neighborhood. And this one obviously looks like it might go over as well, a little bit over 1. Not way over 1, either of them, but over 1 nonetheless. All right, I'll put some arrows and see, I like doing production style here. Doing both at once. And so I'm going to put 0 and then 2 at the far end with 1 whole in the middle because I noticed that these are going to be more. And this is one of these days where I'm glad you're doing homework with me because the tendency, and they don't give you a hint in the instructions, would be to make a number line from 0 to 1, and you would swiftly find that if your sums are more than 1, which they are here, you have to do some erasing. All right, so let's make life simple. Okay, so 1/2. Look, there's 1/2, right? Bing! Okay, so that's going to be our first little jump. The arrow here goes plus 1/2. And now we're going to go 5/8. Okay, so to make some eighths over here, I can do that, right? And then here's 1.5, and I'll label that so we can see where we are. And the same thing here, cut it in half, cut the halves in half, right? 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8, 12/8. Okay, so this all makes sense. So we're going to add 5/8. So 1, 2, 3, 4, 5 will take us to this point, and I'm going to draw the arrow backwards so I don't lose track of where it's supposed to land. That's my plus 5/8. And where does that take me to? Well, 1 and, these are eighths, right? 1 and 1/8. Now, to do this in terms of a number sentence, we are adding, I'm going to write the 5/8 first. Here, I'll go down here. I have some room. Now, the 1/2 is the one we want to put in terms of eighths. And look, I'm not going to pretend that we don't know that 1/2 is how many eighths? Well, what's half of 8? 4. It's 4/8. So 5/8 and 4/8 equals, well, 5 and 4 are, you got it, 9. And then we use a number bond. And again, I'm doing it horizontally here. We pull out the 1 whole as 8/8. And from the 9/8 that leaves 1/8. So in the end, that equals, well, 8/8 is equal to 1 whole. And then 1/8 is, 1/8. There we go, 1 and 1/8, which is what we got up here as well. In fact, I'll go ahead and circle this. Boom. All right. So now, a similar thing here, except that we're just starting with 3/4. So let's go ahead and mark, well, that would be 1/2. And then split the halves in half to create fourths. So there's 3/4, right? So let's go ahead and do our little happy bouncy arrow to 3/4. Ugh. Oh, come on, you can do better than that. All right, yes, I can. There we go, 3/4. And now I want to add 3/8 to that. And so I know what I can do is just if I bisect my fourths, then I have eighths, right? So that's going to be the first one. Now, I have to do something with this whole big space between 1 and 2. Let me mark 1.5. And then here's the fourths. And then split these in half to make eighths. How convenient. And so now 1, 2, 3/8 will take me to this point. I'm going to draw my arrow backwards so that I don't lose track of where it's supposed to land. And so that's plus 3/8. All right, and where did it land? Well, this is one whole right here, right? And these are eighths, right? So 1 and 1/8. So I'll draw a little arrow because I don't have room there. It'll end up looking like 11 1/8 or something. So 1 and 1/8. And let's write the number sentence, make sure we get the same thing. So 3/4 is how many eighths? Okay, now look, we could do that mathematically, but in case it helps you, let's do it a different way. Hey, these are fourths, right? 1, 2, 3. Oh, if I split them in half, they're eighths, aren't they? So it's 1, 2, 3, 4, 5, 6/8. See, there's another way of doing that. So it's 6/8 plus the 3/8. Well, 6 and 3 make 9, and we're talking about eighths using the number bond, which I'm going to do horizontally. I know we often do them up and down vertically, but I don't have the space. So pull out the 1 whole as 8/8. And how many eighths does that leave from the 9/8? Yep, 1/8. And so that equals, well, the 8/8 is 1 whole, and the 1/8 is, 1/8. There we go. And notice, aren't they cute? They gave us the same answer 2 times in a row. Ah, they're so cute. All right, let's go on to, I think we have a C and D waiting for us on number 2 as well. C. Let's see. D, C, D. Oh yeah, sure enough. So same thing here for C and D. We're looking at tenths and fifths, thirds and sixths. And I should mention that they're making this nice and easy for us because in every case, one denominator is twice the other one. If you get into, more complicated denominators, it gets a little more complicated, of course, and you can't do it so easily, of course. But this is good training for us. So this one, 4/5 is very close to 1 whole. So a very good chance we're going over 1 on this one, right? So we'll have a mixed number. And over here, 5/6 again is very close to 1. So again, we're anticipating that we will have a sum in excess of 1 whole. So in both cases, we want put arrows on our number lines. So you're doing this factory production style, assembly line, number lines. So I want to go from 0 to 2 on both of these with 1 whole in the middle. And might as well just hit this one while we're at it too. Assembly line, factory math. All right. So now let's take a closer look here. I'm going to deal with the smaller digit denominator first, the 4/5. So between 0 and 1, I need to create fifths. And same as drawing lines within a rectangle within the space of a number line. To make fifths, I need to draw 4 lines. Okay, so 1, 2, 3, and 4. And that right there is 4/5. So let's draw our happy little hopping arrow. And that is plus 4/5. Oh man, I'm going to fix that. I know. Sometimes my 4s get a little wonky. Forgive me. And now we're looking at tenths. So obviously we know if I decompose, bisect those fifths, factor of 2, I'm getting tenths. So right there, there's a tenth. Now to do that here in this big blank space, let me draw out the fifths. So again, 4 lines will give me fifths. 1, 2, 3, and 4. So I have fifths. See, 1, 2, 3, 4, 5. And then to bisect each of those fifths will give me tenths. All right, so now when I want to go 4/10, it's going to be 1, 2, 3, and 4. And I'm going to draw my arrow backwards so I don't lose track of where I'm supposed to land. So that's plus 4. Oh my goodness, me and the 4s today. Gosh, they are bad luck. Look it up, it's true. All right, so where did I end up? Well, this is one whole, and these are tenths, so 1 and 1, 2 tenths. 1 and 2 tenths. And as I did on some of these, I'm going to circle that so it's clear. Now to write this out as a number sentence. Okay, well, 4 tenths. And let's do it mathematically. With the 4/5, we know it's a factor of 2, right? So 4/5 times 2 halves. We can do this stuff in our heads now, can't we? 8 tenths. Yes, 4 tenths plus 8 tenths. 4/5 equals 8 tenths. So add those up. 4 and 8 make 12. And we're talking about tenths, Ed. All right, so now my number bond, and again, I'm doing these horizontally. I'll bust out that 10 tenths. That makes 1 whole, which leaves how many from the 12? It leaves 2 tenths. And so that equals, well, 10 tenths is 1 whole and another 2 tenths. So my answer is 1 and 2 tenths, exactly what I got there. Boomba! Let's go ahead and do this one. We're going to do the thirds first. So between 0 and 1 to make thirds, I'm going to draw 2 lines to make 3 partitions. And why don't I just jump ahead because I know I'm going to need to do it here. So go ahead, I'll do thirds here as well. All right, so I'm looking at 1/3. So that's going to be the little hop right here, plus 1/3. And now to go 5/6, and I just need to cut my thirds in half, partition them, bisect them, decompose them, however you want to describe it. Double them up, you could even say. So 1, 2, 3, 4, 5, 6. And I'm going to draw my arrow backwards so that I do not lose track of where it lands. So that's plus 5, 6. And where does it land? Well, these are 6, and that's 1 whole. So this is what? 1 and 1, 6. And I'll go ahead and circle that one too so I don't lose track of it. All right, now, easiest way to convert 1/3 to 6 here is, look, I drew 6 all along here except for in this one little space. So boom, it's 6 now. How many 6? 1, 2. 1/3 equals 2 6. And I'm adding that to 5 6, which is what? 2 and 5 make 7, and we're talking about 6, Ed. So I'm going to do a little number bond, pull out that 6 6, my 1 whole. You're getting quicker at this, aren't you? And that leaves how many from the 7? Just 1/6. So 6 6, we just said, is equal to 1 whole, and 1/6 is, well, 1/6. So there we go. Our answer is 1 and 1/6, which is what we got on the number line. Yet we have a number 3 awaiting us. Let's go take a look. Well, thank God Almighty, we are free at last. We only need to draw a model if needed here. We can just like follow this first direction, solve, and we'll write the sum as a mixed number. And so now we're just going to abstract it. We're going to take the concrete models, the tape diagrams, the area models, the number lines, and set those aside and start doing just the mathematics of it. And you'll see, although you're looking, oh, I got 8 more to do here. Watch. We're going to blow right through these like blowing your nose, kid. All right, so here we go. 1/2 plus 6/8. Okay, I know I could put the halves in terms of eighths. Oh, well, 1/2 makes it easy. What's half of 8? 4. So 1/2 equals 4/8. All right, and we're adding that to 6/8. Well, what's 4 and 6? 10. Good. And we're talking about eighths. And then to make it a mixed number, I will bust out that 8/8, the 1 whole, and that leaves how many from the 10? That leaves 2/8. So that will equal, well, the 8/8 is 1 whole, and 2/8 is 2/8. So there we go. See how quickly these go? Yeah, without anything to draw. All right, so here again, we're dealing with eighths, but now we have fourths. So we can easily make fourths into eighths. So 7/8 plus, well, 3/4. So we can do this math in our head. It's a factor of 2, right? So 3/4 times 2 halves. 3 times 2 is 6. So 3/4 equals 6/8. and we add those up. 7 and 6 make 13, and we're talking about eighths. There we go. Let's use a little number bond to make it a mixed number. From the 13 eighths, we'll pull out the 1 whole, which is 8 eighths. And how many does that leave? Well, 8 and what make 13? What's that fact family? Another 5, right? Leaves another 5 eighths. So then 8 eighths is equal to 1 whole, as we said, and 5 eighths is equal to 5 eighths, yeah. So there we go. Final answer, 1 and 5 eighths. This one, another easy one here. 5 eighths plus 1/3, and I say it's easy because, well, thirds are easy to make into 6, right? It's a factor of 2. So 1/3 times 2 halves is 2 6. So 5 6 plus 2 6. Well, 5 and 2 make 7, and we're talking about 6. Now let's decompose it. Take out that 6 6, which is 1 whole, and from the 7 6 that leaves 1 6. 6 6 equals, well, 1 whole, we just said that, and 1 6 equals 1 6, yeah. So there we go, 1 and 1 6. And the last one of this quartet, we see again making fifths into tenths. We can do that. It's just a factor of 2 again. So 9 tenths plus, well, 2 fifths. And by the way, I'm going to write this one out because I've been doing these, just out loud and kind of in our heads. But so this is what we're doing. We're saying, okay, well, 5 times what will give me tenths? 2. And we do the same thing to numerators. So 2 fifths times 2 halves, which is a value of 1. So we're changing the appearance, the form, the name, but not the value of the fraction. All right, so 2 times 2 is 4. So I've been kind of skimming through that out loud, but that's the math of what we're doing in that little in-between step. So 9 tenths plus 4 tenths. Well, 9 and 4 make, got that? 13, yep. And we're talking about tenths, Ed. All right, we decompose the 10 tenths, the value of 1 whole. And how many does that leave from the 13 tenths? Another 3 tenths. And so 10 tenths is equal to 1 whole. That was the whole point of that. And we have 3 tenths, which is 3 tenths. 1 and 3 tenths. All right, we just have another little set like that to do, and we're almost done. Nice work. Well, this is the end, beautiful friend. E and F throw us a little bit of a curveball, but we can handle it. Okay, let's take a look at these. We're dealing with 4/12 plus 3/4. Now, what's different about this? Well, to put fourths, to express fourths in terms of 12ths, we have to do a little bit of thinking here. So I'll write out the math. We're going from fourths to 12ths, so we can add these. You see, in this case, it's not a factor of 2, like in almost everything else, or everything else in tonight's homework. It's a factor of 3, because 4 times 3 is 12. And so to find an equivalent fraction in 12ths, we will multiply 3/4 times 3/3, and we get, well, 3 times 3 is 9, okay? So what we're adding here now, after renaming the 3/4, is 4/12 and 9/12. And 4 and 9 make 13, just did that, and we're talking about 12ths. So we can decompose out that 1 whole, and since we are talking about 12ths, it's 12/12. And from the 13/12 that leaves 1/12. Good. And so altogether, 12/12 is 1 whole, and 1/12 is 1/12. Yeah. There we go. 1 and 1/12 is our final answer. And we'll do out the math the same way here when we look at 1/2, and we want to go to 6. Well, again, 2 times what is 6? Yes, it's a factor of 3. So 2 times 3 is 6, and so we'll multiply 1/2 times 3/3 to find the equivalent. 1 times 3 is 3. And we could have just said, hey, we're going to 6. What's half of 6? 3. That's a way to do 1/2. That works. All right, so 1/2 is equal to 3/6, which we're adding to 5/6. 3 and 5 make 8. And we're talking about 6, Ed. And we're going to decompose out that 1 whole. Because we're talking about 6, it's 6/6. And how many 6 does that leave from the 8/6? Yes, 2 6. Slippery snakes. All right, 6/6. Of course, the whole point of that was that it's 1 whole, and 2 6 is 2 6. There we go. And some of these, by the way, like that one, we could simplify further, but that's not in the instructions or the cards for us tonight. This one is one that, let's go ahead and do this one in our head instead of writing out, because we see it's a factor of 2, right? 6 times 2 is 12. So we have the 3/12 we're given. And, well, 5 6 times 2 halves would be how many 12ths? 5 times 2 is 10. So 10/12. And 3 and 10 make 13, and we're talking about 12ths. Decomposed out the 1 whole, the 12/12. And from the 13/12 that leaves how many 12ths? Yep, 1/12. So final answer here, is this your final answer? 12/12 is equal to 1 whole, and then we have 1/12. And lastly here, similar one, because we see it's a factor of 2 again. That 5 times 2 is 10, so we can say, okay, what we're doing here is 7/10, and then rename that 4/5 as tenths. Well, 4/5 times 2 halves. 4 times 2 is 8. Very good. And we're talking about tenths. So 7/10 and 8/10, well, 7 and 8 are 15, and we still are talking about tenths. So now we can decompose, break out that 10/10 as 1 whole, and that leaves 5/10, which you probably recognize as 1/2, but we are not simplifying here. So 10/10 is 1 whole, and 5/10 is 5/10, yeah. All right, well, look at what you did. You finished. Nice work. Another terrific homework session. I'll see you again next time. It is once again homework time.